Mathematics can be recognized and present in the arts such as paintings, architecture, sculpture, and textiles. You will discover that numbers, ratios, and equations, when used correctly, create beautiful art. M.C. Escher was a mathematical artist. He was left-handed like Da Vinci and Michelangelo. He used geometry and symmetry to create the logic of space and created the illusion of infinity using spheres, columns, and cubes. M.C. Escher did not see himself as a mathematician, but he did approach his art in a mathematical way. Escher was fascinated by tessellations. Tessellations can only use regular polygons, the triangle, square, and hexagon. He used regular and irregular divisions of the plane and created what he called metamorphosis, in which the shapes changed and interacted with each other. Escher used these basic patterns in his tessellations to make a greater variety of patterns. He also continued with these patterns by distorting the basic shapes to make them into animals, birds, and other figures. These distortions had to obey the 3-, 4-, or 6-fold symmetry to keep the pattern in order to keep the tessellation. The effect was dizzying and beautiful. In his woodcut snakes, the snakes appeared to travel into infinity both towards the rim and towards the center of the circle by using shrinking, interlocking rings. Vincent van Gogh was and still is one of the most famous artists in Western art. Van Gogh created one of the most famous art pieces ever known, Starry Night. He studied motion and the turbulence of wind to make it look like there is wind blowing. Turbulence is difficult to understand mathematically, however, Van Gogh was able to depict the way it looks through his art. He created a night sky filled with swirling clouds and stars by using circular motion. This effect is caused by luminescence, an intensity of the colors on the canvas, making his art twinkle, pulse, and flicker. Scientists from Mexico, Spain, and England were motivated to study the luminescence of Van Gogh's paintings in detail. Although turbulence is an unsolved mathematical problem in physics, he was able to perceive and represent this concept. Turbulent fluid structures are hidden in many of his art pieces, where his use of color and brushstrokes capture the mystery of movement, fluid, and light. The golden ratio refers to the Greek phi, which is the 21st letter in the Greek alphabet, or 1.618. The ratio 1 to 1.618 is found in paintings, architecture, and even in decorating when the objects are placed in a sequence to each other. This ratio was used in the building of the Great Pyramid of Giza. When comparing two items side by side with the golden ratio proportion, the largest one is 2/3 larger than the smaller one. Da Vinci was an artist who loved to do painting, sculpting, and architecture, but he was also a very good mathematician. Da Vinci used the golden ratio in most of his work. He used it in one of his most famous paintings, the Mona Lisa. The golden ratio is referred to as the golden rectangle in this piece. If you take sections of the painting, it has the dimensions of the golden ratio. He was the leading artist in the Italian Renaissance. The Penrose tiles are named after a man named Roger Penrose. In a section of Penrose tiles, you will see that the shapes will be in rows with the same amount of tiling in between each one. M.C. Escher used Roger Penrose's idea of the golden ratio to make some of his creative work. He used two triangles from Penrose tiles to make an impossible figure in his artwork, Waterfall. Fractal art is art created on a computer. It is used in animations, media such as Snapchat and Instagram, and in movies and video games. Fractal art is like a math equation, but in graph form. It uses mathematical formulas to make art with a lot of diversity within one art piece. In a particular picture, the formula used will determine how the pixels are composed and shaded. A characteristic of fractals are that they are infinite. You can see fractal art in images that have swirls. The swirls go on and on, going into and coming out of the image. Another art using math and design is optical art. This art creates illusions that make objects look like they are moving, vibrating, or warping. This uses shape, space, and patterns with rectangles, triangles, and other shapes. Optical illusions are usually made up of angles, speed, lines, spirals, triangles, circles, and space, sometimes distorting them to make dizzying effects. The math concepts directly related to optical illusions are geometry, arithmetic, and algebra. Many mathematicians express themselves by not only solving equations but also by producing art. Artists can use math to make something beautiful and amazing. Something beautiful may seem easy to have made, but it really took a lot of time, effort, and thought to create each piece of the image. The end.